This 2023 paper 1 question 1, we're given this absolute value equation to solve. So if the absolute value of something is equal to 11, the thing inside the absolute value should be 11 or minus 11, because the absolute value of minus 11 is equal to 11, and the absolute value of 11 is equal to 11. So basically that means that 5 plus 3m is equal to positive 11, or 5 plus 3m is equal to minus 11, because then the thing inside the absolute value would be 11 or minus 11, so the whole thing's equal to 11. So then we can just solve. So then we get 3m equals 6 on this side, which means m is equal to 2. And for the other one, we would get 3m is equal to minus 16, which means that m is equal to minus 16 over 3. And there are two answers, which you can check by subbing back in. Then we have some algebra manipulation, so we need to express for k. So we can get rid of the fractions by multiplying across, kind of doing a cross multiplication. So we'll get j plus k on the left-hand side when we multiply the j plus k up. And on the right-hand side, we'll get kh. We need to solve for k, so let's get all the k's onto the right side. So let's have j is equal to kh minus k. Then we can factor out a k and say that j is equal to k times h minus k. Sorry, that's not right. I meant k times h minus 1. Apologies. And then you can multiply this out and see that it's the same as this. Then we can divide both sides by h minus 1 and get that k is equal to j divided by h minus 1. And that's our expression for k. Then we're told that this is a factor of this. What's the value of p and r? So the way that I like to do these, you can do long division. It's just a little difficult. What I like to do is say that x squared minus px plus 1. When we multiply that by something else, and I'll get to what that is in a second, we're going to get x cubed minus 2x minus 3r. And that's just because if this is a factor then of this thing, then we can multiply this by something else to get this polynomial. Now, what do we have to multiply a quadratic by to get a cubic? Well, the answer is a linear. And we don't know what the coefficients will be. We'll call them ax plus b. Now you can multiply this out and figure out what all the unknowns are. Or we can notice that x squared times ax will give us x cubed. And you can see on the right hand side we only have 1x cubed. So clearly a has to be equal to 1. You can do that by inspection. There's no other way we can get an x cubed on this side, so a has to be equal to 1. So that's just a little thing we can do to simplify things for ourselves. And then we can just multiply it out. So x squared times x gives us x cubed. Then we'll have plus bx squared. Then minus px squared, when you do the middle term, minus pxb, and then plus x plus b, that's just multiplying the 1 in, that's equal to x cubed minus 2x minus 3r. Now we can compare, because this is an identity, we can compare the coefficients on both sides. So the x cubes don't matter, but I'm not going to write, basically I'm going to get rid of the x cubed, subtract them on both sides, they don't matter. In terms of x squared terms, we'll have b minus p, x squared on this side. In terms of x terms, we'll have plus, and then we'll have 1 minus pb x's. That's just factoring out an x from these terms. And then our constant term on the left-hand side will be b, and that's equal to, and then getting rid of the x cubed, we'll have minus 2x minus 3r. So clearly, the number in front of the x squared has to be 0, because on this side there is no x squared. It's like 0x squared. So that means, because this is an identity, it's always true. That means on the left-hand side, we should also have 0x squared. So that means that b minus p is equal to 0, or in other words, b is equal to p, which is a useful fact. So if b is equal to p, now we can look at the x terms. So if we look at the x terms, we see that 1 minus pb will be equal to minus 2, because they're the numbers in front of the x, as you can see here. And here we have plus something times x, and here you can think about it as plus minus 2 times x. So they're equal, and then we know that b is equal to p. Remember, we're solving for p and r, so I'm going to just replace the p with a b here. So we'll get 1 minus b squared is minus 2. And then we can do the constants. So the constant on the left side is b, and the constant on the right side is minus 3r, as you can see. So if we know what b is, it's probably easy to sub the b into here. So replace the b with a minus 3r. So get 1 minus, and we'll have minus 3r squared is equal to minus 2. So we'll have 1 minus, and then we're going to get 9r squared is equal to minus 2. And then we can bring the kind of things to each side. We'll have 3 is equal to, and we'll have 9r squared, which means that r squared is equal to a third, dividing across the 9, which means that r is equal to plus or minus 1 over root 3. Now we're told that p is negative here, okay? So we have to choose one of these, the plus or the minus, to make sure that p is negative. So sorry, here we said b is equal to minus 3r squared. So really, if I was being clever, I should have replaced this b with a p instead of what I did, but it doesn't really matter because b and p are the same. So this is the same as, well, I'll just leave it the way it is for there. So basically, b is equal to minus 3r, but also p is equal to minus 3r. So we want, remember, we want p to be negative. So if we check our two values of r, so if r is equal to 1 over root 3, the positive one, then p will be equal to minus 3r, and that would then be a negative number, right? And we want p to be negative, so that's good. P has to be less than 0, so that's actually the answer we're going to use. So then p will be equal to minus 3 times r, so minus 3 over root 3, and you can simplify it to be minus the square root of 3. That's just using the index rules. So this is 3 to the power of 1, this is 3 to the power of a half, so 1 minus a half gives us the power of a half, so this is just minus root 3. So p is equal to minus root 3, and r is equal to 1 over root 3, which you could rationalize if you want as root 3 over 3. It's probably a good idea to do that just in case, but it doesn't say anything in the marking scheme. And if we ended up using r as minus 1 over root 3, well then p would have been positive, because we'd have a minus, r would be negative, and then we're multiplying by a negative, so then p would be positive, and we're not allowed to have that. So that's why these are the two answers.